So what we're going to be looking at today is the next section in the book, and we'll be going over this again, today and probably again the next time we have class. And again, just pay attention to the forecast, and what happens happens. We'll just roll with whatever happens. But altitude's in a right triangle. This is a right triangle that's on this picture right here. Okay? So, I'll try that again. There we go. It's a right triangle. What I've done is I've taken the right angle and I've drawn in the altitude to the hypotenuse, so that this is a right angle and that's a right angle. When we do that, we wind up with three triangles in this picture. The outer triangle, the triangle here on the left, and the triangle on the right. And not only do we wind up with three triangles, but all three triangles have to be similar. So this goes right back to the triangle similarity chapter we ended the last semester with. So if this is point A, this is point B, this is point C, and point D. If I look at the outer triangle ACB, it's similar to triangle CDB, because angle C is the right angle and angle D is the right angle. They both contain angle B. Angle similarity, those are similar triangles. Same with ACB and ADC. Both contain angle A and both contain a right angle. One is angle D, one is angle C. And so we have three similar triangles in that picture, is what it boils down to. And we're going to use that to help set up and solve proportions within right triangles. So I can use that, find that altitude to the hypotenuse of a right triangle. So what we're going to do is we're going to split it up. Okay? Through the magic of the smart board, we can do this. And the trick is doing this. We're going to reorient all the triangles. So remember, when we first came out of this, let's keep track of what was where. All right? This angle is A, this right angle is D, and the acute angle is C. So we're going to slide that out. We can reorient that. We can call, this is still angle C. The right angle was D, and angle A is down here. Okay? Same thing here. We can take this one, pull it out, and again, the right angle is D, and we have B that's going to wind up on top this time. Come here. So we orient it the same way, so it's easy to see. But now this is angle B. This is still the right angle D. And this is angle C down here. And finally, we have our outer triangle here. And our outer triangle, C is the right angle. And I'm going to rotate this, but I'm not going to just rotate it. I'm also going to have to flip it. I have to rotate it again. Okay. So the right angle was D, and the way it was oriented originally, the right angle was C, excuse me. D isn't even in there. D is on the hypotenuse. Okay. The right angle is D. B is, yep, the acute angle. A is this angle down here, and C was that angle right there. Okay. So that's how we kind of flip it around. And it can be a little bit confusing when we do that, but once we get them all flipped around the same way, then we can kind of see the similarity. And when we go to set up our proportions, it's going to be relatively easy to do so. So that's kind of the process that we're working on, is we're going to redraw our pictures as three similar triangles, and then we're going to label them and set up proportions to solve problems. And we kind of see this here. So let's take a look at how a problem like this is going to work. And the first one, I'm going to hand out your worksheet right away here. We're going to do the first couple of them together, just so you get an idea of how this process works. And again, like I said, this is not everything we're going to do in this section. We will review this again next time we have class, but realize that this is one of the more challenging sections sometimes for people. Now the first one I've all set up for you. And you can see that we had a right triangle. And there was the altitude. And we had 16 here. The whole thing was 25. And x was over here, my unknown. And it said set it up for x. So what I did is I reoriented all the triangles. And my original drawing here isn't so good because it looks almost isosceles, so I'm going to redraw that. So it's very clear which side is which. Okay? You have the long side, the short side, short leg, and the hypotenuse. Okay? Not quite to scale, but I'd rather have a little exaggeration here for the purpose of illustration. So you have 16, the whole thing is 25, and we want to know x here. So what I've done is I've redrawn all triangles in the same orientation. So big triangle, or it doesn't matter, I drew the small triangle first. Okay? The smallest triangle I drew first. And I'm going to shrink that down just a bit. Whoops, didn't group it all together. So let's try that again. Sometimes the smartboard doesn't do everything you want it to do. I'm just going to group those. Hold on. So I get a simple picture. There we go. There we go. Good. So I'm going to shrink that down just a bit so it's a little bit easier. That's a small triangle. Okay? My smallest triangle, the shortest side, I can figure this side. If this is 16, this is 25, how long is this piece just from here to here? 9. Okay? So my shortest side is 9. My hypotenuse is what's unknown because that's the right angle. And I don't know anything about this length right here. So we just fill in what we know. What we don't know, we just leave blank for now. Okay? My second triangle is going to be this one. I'm going to reorient it so it's the same way oriented as this one. Okay? Now, my short leg, I don't know. I know nothing about. My hypotenuse, I know nothing about, but I do know my long leg is 16. Then I have the large outer triangle. And again, I'm orienting it exactly the same way. In the large outer triangle, the short leg is x. The hypotenuse is 25. And the long leg I don't know anything about. So just fill in the information I have. Now, I use 2 of the 3 triangles to set up a proportion. The one I'm not going to use is the purple one in the middle here because I only have one piece of information. Not enough. But I know the hypotenuse and the short leg, hypotenuse, short leg in both these triangles, don't I? So I can compare hypotenuse to hypotenuse is short leg to short leg. And I can solve that proportion, can I? When I solve that proportion, I get x squared equals, and I have to go 9 times 25, which is 225. But I know how to solve that. X squared is 225. I just take the square root of both sides. So x is the square root of 225. So x is 15. So now I've learned that that x is 15. So now we have 15 and 15. Now for now, that's as far as we're going to go. We're just going to solve for that one x. But I think you can see now I have all these right triangles where I know 2 sides. 25 and 15, I could use Pythagorean theorem to find that side, couldn't I? And this one's 15 and 9, I could use Pythagorean theorem to find that side. And guess what? That side is one of the sides in this triangle, and now I could use that to solve everything I needed to solve. So we can set up these triangles and set up proportions to do it, which leads us then later on into the Pythagorean theorem. For now, all we're worried about is finding the one unknown. Let's look at the next example. Next example, the altitude is my unknown. That's okay. We're always going to be thinking in terms of long leg, short leg, hypotenuse for each of my triangles. That's my x. This is 9. The whole thing is 25. Again, So this has to be 16 right there. So I'm going to start by drawing the large outer triangle first this time. Orient the same way. The hypotenuse is 25. That's all we know, right? Next, let's do the middle triangle here. I'm going to orient it the same way as my large triangle. There's my right angle. And we're dealing with this triangle. If that's my right angle, my short leg is x. My long leg is 16. I don't know the hypotenuse. Everybody see how I'm getting those numbers? We want to think in terms of short leg, long leg, hypotenuse. Third triangle is the one over here. So again, I'm going to reorient it so it's the same way as the other two triangles. And what do we know? Well, I know my short leg is 9. My long leg is x. My hypotenuse, got nothing. This triangle, the large one, I only know one thing about. We're not going to use that. These two triangles, I know both the short leg and long leg, or at least I have values there for the short leg and the long leg, don't I? So what am I going to do? I'm going to set up a proportion. This 16 goes with that x. This x goes with that 9. Again, we cross multiply. I get x squared. 16 times 9 is 144. So x is the square root of 144, which is 12. So now I've learned in my problem, we've solved that altitude is 12. Once I know that that's 12, now I could go back and solve the other information that I need using Pythagorean theorem, if I needed to do that, which we aren't going to ask you to do yet. But this is how we work with altitudes in right triangles. Now, we've just done 2 of them. You have 6 more to go, and the answers are on there. A couple of them are a little trickier because the sides aren't whole numbers. Now, by the time you get to number 5, you get a side the length of the square root of 33. It really doesn't matter because you're still going to do the same thing. I mean, if I take a look, say at let's just get number 5 set up for us. We still have a couple minutes. Okay, x is this whole side. 33 is this length right here. And 7 times the square root of 33 is right there. Now this one is a little bit different. We're going to have to be a little ingenious with this, but that's okay. We can still set up our picture. Large outer triangle. Right angle. Don't know this side. I know this side is 7 root 33. I know the hypotenuse is x. Second inner triangle. Okay. Going to reorient it so it's the same way as the large outer triangle. Right angle, hypotenuse is 7 root 33. Short leg is unknown, long leg is 33. Can pretty much stop right there, can't I? Because there's my proportion all set up, ready to go. I really don't need, in fact, this triangle, this small triangle, I don't know any information about that at all. There are no values for that, are there? Set up our proportion. X over 7 root 33 equals 7 root 33 over 33. What do you notice about that diagonal? The same value, right? So when I cross multiply, and this is a little trickier, but I get 33x equals 7 root 33 times 7 root 33. Now you may think this looks difficult, but actually it's going to work really nice. 7 times 7 is 49. Root 33 times root 33 is 33, right? So 33x equals 49 times 33. I'm not going to actually multiply out the 49 times 33. I don't have to. Because how am I going to solve for x? I'm going to divide both sides by 33. Cancels. Cancels. X is 49. And there we are. So there, now we've done 3 of the 8 problems that you have for Monday. It's a process that requires practice, and you have to always be thinking in those terms. Short leg, long leg, hypotenuse. Exaggerate your picture so it's clear what's short leg, what's long leg, what's hypotenuse. Always be referencing back and forth. You've got to slow down, take your time with this. This is not something that goes quickly.